Hello everyone, welcome back to yet another web dev tutorial. On this video we're going to be talking about clean architecture. It's going to be a little bit of a different video than the rest of them. This is more basically to explain what clean architecture is, how I understand it and how I use it in my projects. Now, if you are looking into clean architecture, you've probably come across to something like this, which basically is an illustration of how clean architecture works. Now let's go over this illustration and quickly point out a few things to basically understand what clean architecture is and what it tries to achieve. So this is called the onion architecture. There's other names for it as well, but we're gonna call it clean architecture. And these are the four different areas of clean architecture. Now the most outer layer is frameworks and drivers. Most of these are gonna make sense after, by the way. So this is all the external interfaces, basically how you connect to a database, which database you use, all the devices and web applications and whatnot. If we go one layer inside, we have gateways, presenters and controllers. This is basically the interface adapters. Basically all the controllers go here, all the presenters and stuff like that. Pink orangey layer here is the use cases, or this is the application business logic. And again, this will make more sense when we actually go into an example. Then the last circle we have is entities, and this is where the enterprise business logic lives. For example, if you have an entity of user and you want to validate the user's username and password or whatever, this is where that code is going to live, because that's business logic for the entities. Now you'll see all of these arrows here, and that means that the dependencies should flow from the outer to the inward of the circle. For example, the entities shouldn't really depend on what kind of database you use and the code of that database. You should only care about the enterprise business rules. And the last thing, we have the flow of control. We have controller and presenter. Basically the flow goes from the controller to presenter, and all the other things, which again, I'm not going to really go into them, but hopefully this will make sense when we get into the code and into the example. And the most important thing to remember about this is just a guide. This is something someone built to help them or their team. And you can find a lot of different frameworks or architectures out there, or guides of how you should develop your applications. But the point with these things is to realize what works for you and your team and implement those as a set of rules and guidance when multiple people are writing code in the same code base. So the biggest takeaway for me from clean architecture is, where should certain code live? Like, where does the business logic live? Where does the application logic live? The dependency flow, which layers should depend on which layers, and the dividing responsibilities. Now let's take a step back and actually talk about what kind of problems does clean architecture solve. If you worked on a team with multiple engineers, you've probably realized that it can be hard to set up any kind of rules or guidances about your code base. This is especially a problem for new teams, or when you have teams with a big number of churn, or essentially when people just leave and go and new people come in. Trying to come up with one set of rules is going to be different, because everyone has different skills, everyone has different experiences, and everyone's going to try to bring their own skills and the way that they do things into the code. Another problem that this resolves is, for example, when a project grows more complex and more complex, it can become very difficult to add new features or to do basically anything in the code if the code base is not set up properly. Now, clean architecture solves this by dividing responsibilities. For example, if you start a project and in the beginning you're using SQL, but then you realize you want to switch to MongoDB. Now, if you follow clean architecture, this should be pretty simple. And lastly, clean architecture can be very good to implement domain-driven development, which I'll go into in another video. Clean architecture provides us with multiple principles that we should follow to set up the rules in our code base. Now let's go through some of them to basically showcase how clean architecture can be implemented and how to follow these principles. And before we start, it's really good for me to mention that the code I'm gonna use here, it's not gonna be the cleanest clean architecture, but it's gonna resemble and follow some of the principles in clean architecture. The first principle we're going to talk about is called the Dependency Inversion principle. This is what I mentioned when looking at the picture. Basically means that dependencies should only go in one direction. They should go from the high-level components with the business rules and entities through the interfaces to the low-level components like infrastructure and frameworks. Or in practical terms, no business logic should ever depend on the framework, the interfaces, the databases, or any technical implementation of this. Now, let's go in the code and show you how I've set up Inversion here. The project I have set up here is a Node.js app, and this is using the Koa router and the Koa body to set up some paths for my API. If you can see, all of this code is in infrastructure. So this is basically setting up the KOA REST API and all the things that it needs to work. And if we go to the routes, we'll see that user and the user ID parameter are basically invoking the get user controller. Now in the controller, so this is now going to the application folder in controllers. So this is where we get into controllers and whatnot. So receives the context, which is a KOA context, tries to get the user, which is a use case of getting the user, and if there's an error, just throws the error back to the response. Now this is how KOA works. So this is gonna do this specifically for KOA. Now we go to get user. Now this is now the use case, and this is where we get into the enterprise and business logic for our application. So here we're not caring about what kind of framework we're using or how it's gonna work and how it's gonna be displayed to user, but basically we are only caring about application logic. So we're trying to get a user, and if the user is not found, this is the message we wanna throw back to the user. So this is application logic. If we go one step further, this is the user entity, and this is where we get user, or we have other methods here, which basically is our business implementation. For example, the can user view profile method is going to determine if certain user can see a certain profile. For example, the rule for now is if the IDs are the same, but you can add any kind of complex business logic in here. But the point is, this is where all that business logic should live. The use cases shouldn't really care about the business logic on that granular level. The controller shouldn't even worry about the business logic at all. And the infrastructure code should not really care about how everything is implemented. So at the moment I'm getting a user from a array, but if we had a database, the entity code should not really care about how we're gonna get the user or where it's gonna come from. This is how we can define a get user, and this is basically infrastructure code. If we had a database, this is where all that code is gonna live. Because I don't have a database, I can just define a method here that accepts user ID and returns the user. Now we can change this to like that. So now that the entity doesn't care at all how we're gonna get that user. And now I'm using an array, but in the future, if I want to implement a database, I can change only this code and everything else should just work. And that's the beauty of clean architecture. The next principle we're going to talk about is the interface segregation principle. Now what this basically means is the interfaces where we actually define the methods, they should be divided into its smallest functional object. For example, if we have an interface that has 5 methods and one object uses the first 3 and another object uses the last 2, then this means we can probably separate those methods in 2 different interfaces. And I'll give you an example here. I have an entity here called user, and I have a get user, can user view profile, and view profile methods. Now this would all kind of make sense, but in the routers I have one route to get the user controller and another route to view the profile. So the get user controller will only use the get user method, and the view profile use case is only going to use the other 2 methods for the user. For example, the can user view profile and the view profile. So this means that we can basically divide the entity into 2. We can divide the user entity into get user only, and the other entity can be can user view profile and view profile. We can call this profile entity or whatever. You see my point here. This is basically how we can segregate the interfaces or entities to follow the principle of segregation interface principle. Now we've come to a single responsibility principle. This principle says that each of the modules should have one and only one reason to change. Now I'm going to give you an example. If I have a route for the user's taxes and I have a taxes controller which has send user tax email use case. Now in here, this is basically calculating the taxes and sending an email to the user. These are two different use cases basically. If we have a reason to change how we calculate the taxes, for example, if the tax rate increases, that's one reason to change. And if we change the email or the subject or the body to the email, that's another separate reason to change this file, which means we are breaking the single responsibility principle. If we want to follow that principle, we would divide this in a separate use case where we only calculate the taxes and another use case for sending an email for the user's taxes. And both of them will be called in the taxes controller. And I'm just gonna write some pseudocode here, but we can first get user taxes with the user ID and year, and then we're gonna send the user tax email with the taxes. So this now represents two different use cases, and if we ever need to change how we calculate the taxes, we're only gonna need to change one file. If we ever need to change the email that's sent about the taxes, we can change only different file. That's how we follow the single responsibility principle. And there's a lot more principles I think about clean architecture. The last one I want to mention is called common closure principle. Now this is just a continuation to the single responsibility principle, where a method should be in an interface or an entity only if it makes sense to be in there. But basically, if you follow the principle where the file should only be changed for one reason and one reason only, then we can think about, does this logic make sense to add it into this file? What are the reasons that this might change? Is it the same as the rest of the file? And that's how we can come to the decision whether any kind of logic should live in any kind of place, basically. Now, the good things about following clean architecture of these principles is, like I said, if we want to change how we get the user from the database, we only need to change one file, or all the files related to the database. If you want to change the logic how we calculate taxes, we only need to change one file. If everything's ingrained in everything else, that means it's going to be very hard to make those changes in the future. For example, services get deprecated, maybe SQL is going to decide it's not going to make the database anymore, and you won't be able to use it in the future. So you'll need to change a big part of your infrastructure for that. And following these principles is going to allow you to make that change easily and as effortless, I can't say the word, and with the least effort possible. Now, I also want to mention that if you really want to make your code at the cleanest architecture possible, you should be using dependency injection. And some of the frameworks already allow this. For example, I think Laravel already has this inbuilt, and there's also similar frameworks for Node.js that actually have dependency injection already into them. Now, the way you can do dependency injection is basically, if you want to follow all the dependency rules about clean architecture, the entity should not depend on the codes for the database. The thing is, if you're importing the method for the database to get users, for example, that still means it's dependent on it. The way you do dependency injection is you define the dependency in the parameters that you're passed to the function, and then you use it. So this way your function doesn't really care about what get user is, it just knows that it's going to be passed in the parameters to the function, and then you use it. And then this can be passed down from the controller, and the controller can pass the same function to multiple use cases and multiple entities. That's just a very simple way to explain what dependency injection is and how it works. But I personally don't really see the difference in any of that. I would rather just import the function into my entity and use it then. When researching for this video, I realized there's this thing called Pragmatic Clean Architecture. And the idea with Pragmatic Clean Architecture is you follow the principles and rules of clean architecture and break them when it makes sense for your team. Now, this is basically what I've done here in this example. I don't really believe in all of the principles that clean architecture is saying us, but I've already mentioned what the biggest takeaways are for me and the biggest helpful things that I can use in my code from clean architecture. That's it for this video. I hope you liked it. I know it's a bit different from the other ones. It's more explanatory than coding, but I hope you liked it. I hope you learned something. If you have any thoughts or any feedback, put them down in the comments below. I value everyone that comments, and I go through all of the comments in all of my videos. Subscribe if you aren't already. I'm only gonna be making more of these. And yeah, that's been it. Enjoy the rest of your day. Happy coding.